Hello everyone, welcome to my channel. So today we are going to do Leetcode Daily Challenge, Maximum Profit in Job Scheduling. We have in jobs and where every job is scheduled to be done from start time to end time, obtaining a profit time. So basically three areas are given to us and you are given start time, end time, profit areas, return the maximum profit. So what we are required to do is we are required to return the maximum profit and the condition for returning that maximum profit is such that no two jobs in the subsets with overlapping time range. Means uh, basically what we are required here is, see, here we are having this one as one of the job, one is this one, right? Other one is this one, and the other one is this one, right? Total four jobs are given to us, and they require that the maximum profit should be returned in such a manner that the maximum profit of the jobs which we are returning, they shouldn't be overlapping basically. So here we can check that 10 and 40, both of them are overlapping with each other. 50 and 10 are overlapping with each other. Then 10 and 70 is also overlapping with each other. 10, 40 only, right? So the only jobs which are not overlapping and also earning us the maximum profit is 50 and 70. Because here you can see that it starts from 1, it's at 3. Then it starts at 3 and ends at 6, right? So that's why our answer would be in this manner only, that we will be returning we will be returning 120, which is basically sum of 70 plus 50, means first and fourth job, whose time range we can check here, right? Now for this one, here if we check for 20, right, start from 1 and end at 3. Then at 3 two jobs are starting. One is basically not starting, but at 3 there are two jobs which are there. This 20 was already started at 2, so it is overlapping. But this 100 just started at 3, right? But now let us go ahead that how we can do the same. So here if we move ahead and if we try to have both of them in 20 and 100, then it would be 120 so far, right? But then if we check that 20 is there and then if we add up 70 to the same and then 60 to the same, these three are overlapping and also their maximum profit is basically greater than 120. That is 150, right? So that's why in that context we will be having this 20, 70 and 60. Now comes the part that how we are required to do this. So basically while doing this, we are required to check that at every point, what is the maximum profit we can earn. But side by side, we need to check that till now what was the maximum which was being obtained and are they overlapping or not. That's the thing which we are required to check. So at every point regarding the maximum thing, we would be required with the priority queue. So in the priority queue, it will be sorting by itself that whatever, if we take the max priority queue, then in that sense, whatever is the maximum would be at the top. But if we take a min priority queue, so in min priority queue, we would be able to figure out with all those as well, which are not overlapping, but they can be added up. Here you can see that if we would have taken our max priority queue, then surely 100 would have been there only, right? And 20 which is there. So our answer would have been somehow 120 with the logic which I'm explaining. Means popping out everything from whatever is being given to us and then adding them up for the maximum profit. But we would have missed some cases because here you can see because this one is the one which is having the less profit than our 100, right? But the starting and according to starting and ending time as well, both of them are potential candidates. But if we check for the 70 and then if we go ahead with 60 as well, then we will be easily able to add that up with this 20. And because of this thing only, we are able to easily return our answer. So that's the thing here. Now for this one, we have the maximum profit as 6 because here we check with the ending time of ending time of this 5 and 6. 2 is there, which is basically greater than our starting time of 6. So that's why it is overlapping. And then we check for 6 and 4. Here also, both of them are overlapping. So that's the thing here. Now comes the part for this one that start, length, and end time. And this basically they could go up to 10 raised to power 4. So accordingly, we are required to manage the time complexity. And start time and end time, both of them can go up to 10 raised to power 9. And the profit 10 raised to power 4. So basically, if we check for the at what it can go here, that is fine. But only thing we are required to check about the constraint is this part. And accordingly, we will be going ahead with the what we say regarding the solution. But that's for sure that we will be requiring with a priority queue. So accordingly, we will be working ahead. So now I've already coded the same. Here I'll explain the code that how we are required to do. So the first thing here would be that we will be taking this as the auxiliary state. This would be jobs in n-square auxiliary space. This is for the fact of storing our start time, end time, and the profit. Basically, because of storing in this manner, we can easily map it after sorting the same. So that's why we are doing it like this. So here, first we are just mapping all of them means whatever start time is there, end time is there, and profit is there, corresponding to that ith index, we are directly pushing that to our jobs, and then we are sorting them. This will be sorted according to the start time which is there. So that's why we are sorting. First according to start time, and if both of the start time are equal, then according to the end time, and then if end time, start time, both of them are equal, then according to the profit. So that's how it would be sorted. And at the end, we are returning this max profit, and what is being there in this max profit is hmm. So now max profit, we are basically taking a priority queue. And this priority queue is basically here we have taken greater of vector of it. In the C++, we have max priority queue. But now as we are doing like this, so it is a main heap sort of, it is a main heap. And here the data structure which we will be using internally is vector of vector in basically a 2D vector where we will be storing the end time which is there and the profit which we will be earning that we will be storing. So that's why we have taken this 2D. And now comes the part that how we will be using this vector. So for that fact, not the vector, the priority queue. So for that fact, we are traversing the what we say it, the jobs which is being given to us, not given to us, but we created. So this n, basically we will be first traversing whatever we have created, and from that we will be taking out the job of I, job of one, and job of two, which are basically our start time, end time, and profit only. And then we are required to do operations on a priority queue. And how we are required to do operation on a priority queue is first we will be checking that if our priority queue is equals to empty or not. If it is not empty, then surely there is some element, and even the start should be greater than equal to the priority queue top dot zero. And our priority queue top dot basically that zeroth would be having the end time. And if our start time is basically greater than our end time, then we can easily check that there are no overlapping. Then we can there are no overlapping intervals which are being there. That's why we are required to have the start greater than equal to this end. Here you can check that. See here in this example, if we say that we are having this and then we are having this, right? So here the top would be having the minimum element till now, right? Minimum as per the ending time. And we will be starting from this one. And our next one would be this one. So here the ending time is this. right? 4. And at the starting time would be 1. So 1 is basically less than 4, right? So that's why here it would be overlapping. So that's why we won't be entering in through this while loop. And first we will be directly pushing whatever is there. But here the priority queue is also empty. So this you can directly say for the case when we are taking this one. So in that case, we will be having the same. Now the as it won't enter the priority queue, right? Because of that fact. But if it would have been entered, then how it would be like? Then first thing it will be checking would be the maximum profit till now and whatever is being stored in the second part of our priority queue. Means in that index, the second element which is being stored that is our profit only. So that thing we will be checking here. Now we will be directly pushing in our priority queue what we will be pushing end and the profit plus maximum profit which we have earned till now. Basically, every point we are accumulating the profit, right? So that's why we are adding this maximum profit earned till now and whatever profit is of the present element which is being there. Because till now we hadn't added the profit of a present element to the priority queue as well. So that's why we are adding like this. So that's the thing which we are doing here. And now comes the part that when our priority queue is still not empty, but there are still some instances where you are checking for the conflicting parts. So uh, we will be here just comparing with whatever max profit was there till now, till top, and then that max profit we will be updating from here and popping out the element from the priority queue so that till now whatever maximum profit is there that we can easily collect and then at the end we are returning our maximum profit. So this is what we are required to do in this particular question. Now comes the part for the type complexity and the space complexity for the same. Here it would be required to return. So the space complexity because of this become n square and time complexity here we can check that we are that is order of n type only. Here time complexity is order of n only. Mm. And sorting that is as order of log n. And then comes the part that when we go inside this priority queue, it will be taking us time complexity, order of n log n, and this order of n. This whole thing I've already calculated above. This whole operation is as part the priority queue, and this will be as per the size of priority queue, which could go at max n. So overall, if we check, then our time complexity is basically log n plus order of n log n plus order of n. So in short, our time complexity would be order of n log n and the space complexity is order of n square. So this was all about this question. If you have any doubt, you could comment that down. And yeah, this was all. Thank you.